Hey, hi, am I audible?
Yeah. How's it going?
Okay, I'm good, I'm good. How are you?
Can't complain.
Cool. So basically, 40 to 45 to 50 minutes we'll focus on coding problems,
Mhm.
and last 10-15 minutes I will try to give feedback like what could have been done better or what I like and what you could keep doing.
Cool. Sounds good.
Yeah. So yeah, this is the first question. So basically, you have a directed graph, and you have to find the length of the longest path from all the nodes. So, for example, if you consider 0, you can go from 0 to 1, 1 to 2, 2 to 3. So the length of the longest path originating from 0 is 3. And if you consider 1, the length of the longest path originating from 1 is like 1 to 2, 2 to 3. So it's 2. And similarly for 2, its length 1 because there is just one edge from 2 to 3. And
Mhm.
there is no edge originating from 3, that's why 0. And for 4 to 3, it's 1 because you can go from 4 to 3.
Mhm. Mhm. Gotcha. That makes sense. And I'm trying to determine whether I should be worrying about cycles.
But that's a good problem. That's a good question. Uh, we can assume that for first part of this problem, we can assume that there are no cycles. It's
Mm.
directed a cyclic graph, and once we solve it, maybe we can introduce
Okay.
how to deal with
O-
cycles.
Okay, that sounds good. So I'm just gonna select language here just to make sure. Oh, sorry, I erased your whole.
No
Oh, okay,
problem.
it's still there. Cool, cool, cool.
Right.
And then I'm just going to run this to make sure I understand how this works. So it's just going to loop through this array and then return all these strings here. Okay, great.
Don't worry about running it. Yeah, I we can just consider that you need to write one function, and we won't run it. Yeah,
Oh, okay. Okay, I gotcha. I can write this out. Just static void main string.
not even main. Like we are okay if like we just
Oh, okay.
talk about
Okay.
the function which takes this,
Okay.
and yeah,
Cool. Cool. So I'll start by just kind of explaining my initial thought process.
sure.
Um, so I think um, so the input is it just going to be a list of tuples?
You can assume that you have whatever format you want this input to be, you have it in that format. I'm okay with it. I'm even okay if you can, if you assume there is a graph class and it provides you the whatever APIs you require.
Mm, mhm, mhm. Gotcha, gotcha. Okay, so I'm thinking just to kind of keep the input simple, it's just going to be a lists of integer.
Adjacency list.
Yeah, yeah, exactly.
Okay.
And then that could look something like here's the outer list and then the inner list, and like you had mentioned, 0, 1, um, 1, 2, and then I'm
Okay.
missing I think an outer bracket, etc. Um, and then so the first thing I was thinking about doing, and something um, I like to do in a lot of graph problems, is just to basically loop through this list, this input list, and then create a
hmm
hash map. And then
Yeah, so you can assume you already get an input as a hash map. Don't worry about processing
oh,
this
okay,
list into hash map. You
okay,
can already assume that you have an hash map as an input.
okay, gotcha, gotcha. And then sorry, I may have missed originally. This output list is this isn't in order. It
Yeah,
doesn't need to be in.
yeah. So basically, one more factor is like your graph has n nodes. I just missed it. Yeah, it has n nodes, 0 to n minus 1. So yeah, they are numbered 0 to n minus 1. They are not scattered nodes. So yeah.
Mhm, mhm. And sorry, I didn't quite get the output is supposed to be an ordered list,
Yeah, yeah,
ordered
it should be
ordered path rather.
right. No, it's like, for example, the longest path originating from node 0 is of length 3, 0 to 1, 1 to 2, and 2 to 3. That's why index 0 has
Oh,
3. And
gotcha.
the longest path originating from 1 is like 2, 1 to 2, and 2 to 3. 2, that's why at
Oh,
index 1 it's 2.
oh, okay, gotcha. So you're saying that the output is basically the number of nodes in the graph.
Yeah. The output size is
Okay.
number of nodes in the graph, which is
And
an,
then each
yeah,
index in the output. So like index 0, you have 3. That means that there's the longest path for node 0 is
is of
3.
length 3. Yes.
Okay.
Yeah.
Okay. Gotcha. So yeah, so the input's a hash map, and I'll definitely be using some sort of depth first search
Mhm.
to determine the longest path per node. So I can
Mhm.
start by just looping through the hash map,
Mhm.
and then for each node,
Mhm.
performing a depth first search.
Mhm.
And then once I do that, it's just for each node, it's just getting the max depth of that kind of graph or tree structure. Basically, it's almost like a tree structure at that point.
Mhm.
Um, and yeah, yeah. So I can start by writing just, I think there will be two functions. One function will be kind of
Mhm.
iterating through each node in the graph. And
Mhm.
then the second function will be the actual depth first search function.
Awesome.
So this is going to return an integer, and it'll be get longest path. And like you said, we're going to make it a map, and this map is going to have an integer as the key and a list. Ooh, gotcha. List of integers as the value, and that's just kind of like the children.
Mhm.
Uh, and then we'll just call this graph. Is is all my syntax correct? I think so. I'm not sure why I'm getting this. Records.
Don't worry about these things. Like, yeah.
Gotcha. Hmm. Okay, cool. So I'm gonna go ahead and so we'll do. Oh, it's sorry. The output's supposed to be
The list of integer. Yeah.
a list. Yeah, yeah. So list of integer. And so we'll add that as the result. We'll call this res new array list. Uh-huh. And then this is just this will be of size like at the end this is going to be a size graph dot size basically.
Mhm.
And then we'll loop through map dot entry the map. And yeah, this is going to look like this. Entry um, graph dot entry set. And then what's going on here? Cool. And then we can basically do like res dot add at entry dot
Mhm.
get key
Mhm.
and then DFS like that. Does that make sense? So this will insert the entry at the longest path at index whatever uh,
Right.
the
Right.
the node is. Does that make sense?
Yeah.
Cool.
And whatever the
Oh,
answer DFS gives. Right. Okay.
exactly. So I'm going to go ahead and write the DFS function
Mhm.
private, and it doesn't need to be private, but I'm just DFS. And then an important thing to think about is what the input is going to be and what the base case is going to be.
Mm-hmm.
So let's see. I'm gonna make yeah. So I'm gonna make the graph a global variable, um,
Mm-hmm.
so it can be accessed from the uh, DFS function without having to pass it in as an input.
Mm-hmm. Mm-hmm.
This dot graph equals graph. Cool. Yeah, that looks fine. And so then we're just going to pass in basically all we need to pass in is the integer that we're trying to get the longest path for.
Mm-hmm.
Let's see, node. We can actually make this integer node, and then for the base case, we might not need a base case. We can just like
Mm-hmm.
loop through the children of the node, so we can get like the children. Children equals graph dot get node, and
Mm-hmm.
then we can loop through the integer child children. Cool. And then we can do like int res equals 0.
Mm-hmm.
And then let me think really quick. So this is going to be a list of children, and then we loop through each child. And for each child, we're going to make another recursive call. So this is supposed to, and then we can return res plus 1. Okay, yeah, I'm just trying to think about how this recursion is going to work, basically.
Mm-hmm.
If we pass in, say, 0, then 0 will only have 1 as a child, so we'll loop through that, and we'll pass in 1, and 1 will have no children. And so we'll get just 1 as the path length, and so we'll have to res equals math.max res or path length. So yeah, we pass in 0, and then we get 1, only a list of length 1. I'm just thinking about this kind of input example. A list of
Mm-hmm.
length 1. We loop through that
Mm-hmm.
list of length 1. We pass DFS. It doesn't have any children, so this is going to be, or it does have children. I'm sorry, but I'm going to assume it doesn't have any children just for the simplicity sake. So say it doesn't have any children. It could be null, so I need to handle like a null case. Get no. Actually, I'm going to assume the input. If a node doesn't have any children,
Okay.
it'll be an empty list. So the
Makes
key
sense.
will be the node, and then it'll be an empty list. So I don't need to I'm just going to make that assumption for now.
Sure.
And so no children, 1. And so yeah, I feel like initially I'm thinking that this recursion will work. So I think I'm going to give that a try.
Um, like yeah, for any recursion, do you need some base case, right? Like when you will end it, what will like okay.
Hmm. Yeah, so I'm thinking. So correct me if I'm wrong, but
Mm-hmm.
I think basically no, since we don't have a cycle,
Ah, right,
uh,
right, right.
like
It will end
this,
with for the
yeah,
some
there's
last
no
node.
children.
Okay,
Yeah,
right.
because there's going to be no children, so we won't instant or invoke any more recursive
Hmm.
calls, basically,
Hmm.
if that makes
Right,
sense.
right. Do you need to add a return statement in your first function?
Can you say that once more?
Yeah. Do you need to add a return statement in the first function?
Yeah, yep. For sure. So, it's yeah, uh-huh. So we just return uh result,
Mm-hmm.
and
Cool.
so,
Yeah, I think yeah, this should work. What would be the complexity of this?
mm. So we're gonna, so here I don't know if you can see what I'm highlighting.
Mm-hmm.
But here we're looping through every uh node in the graph. So
Yes.
let's say like um every node in the graph is like of n, and
Mm-hmm.
then we're performing um, a recursion for all its children.
Mm-hmm.
Um, and so, yeah, it's the time complexity for graph problems is always a little tricky. Um, but for any sort of like backtracking or DFS,
Mm-hmm.
um, where basically it's a lot of the times it can be like the number of recursive calls. So let's say on average we have like two or maybe three recursive calls um, per node, uh,
Mm-hmm.
like three children, I mean, uh, and then it would be to like the power of the total number of nodes, or something like that. Does that make sense?
Do you know the complexity of the first search in terms of if there are n nodes and like if I say like a graph has with n nodes and
Hmm.
m edges, but do you know the complexity of one DFS on this graph?
It would be n times m, no?
N times m.
Yeah.
Okay.
Is that right?
Uh, I'm
Oh,
afraid like
sorry, you don't think that's right?
right. Yeah, I don't think that's right.
Okay, gotcha. Yeah. Okay, so let me think more then. Uh, hmm. So,
So you consider like there are how many times you will visit any edge in a
mhm.
graph
How many times will I visit an edge in a graph? Uh,
for one call from for one of this call.
it will be. It could be. I I want to say one.
Mm-hmm. Yeah, that's correct because like you will visit that edge when you are at source node of that edge, right? And you are going to
Hmm.
child of that. So
Yep.
you will visit every edge just once, and you will visit at max once, not every time you will visit it.
Yep.
And you can visit. Mhm. And how many times you will visit nodes?
Once.
Yeah.
Hmm. Yeah. Yeah, definitely something I need to kind of brush up on is time complexity of graph problems. Uh, I'm honestly like a little. It's funny that you asked me a graph problem. This is something I'm studying right now, and
Oh,
it's
okay.
something I've been kind of struggling with the time complexity on. I'm really good with like recursion and DFS and stuff like that, but
Mm-hmm.
for some reason determining the time complexity for these is a little bit difficult for me. Um,
So
yeah, to be
yeah,
honest.
I can understand. Yeah, I've been in similar situations. So yeah, don't stress about it. So basically, you analyze it by it's not a straightforward analysis. I know that.
Mhm.
So, but like the key here is that you will visit every child-parent relationship only once.
Mhm.
That's why you will visit every age at max once, and you will
Mhm.
iterate through all the nodes. So it would be one n plus n for one of the recursive you call, but you will call that for n times. So it's basically n into
Mm.
n plus n because you are
Ah,
calling iterating for n times. So this is
yes.
the first n comes from this for loop,
Mhm.
and n plus m is the complexity of DFS. Because if you consider DFS, right, so you will reach every node and you will
Yes.
reach every edge once.
Okay. Okay. In worst case.
Right.
Gotcha. Gotcha. That makes sense. That makes sense. N times n plus m. Okay. Got it. Got it.
Mm-hmm. Okay. So yeah, I think yeah, you solved it. But like, do you think you can optimize it somewhere?
Hmm. Yes. Yeah. Yeah. I was actually thinking about that briefly.
Mm-hmm.
Um, because in each depth first search,
Mm-hmm.
um, as you're uh, you know, uh, traversing the graph,
Mm-hmm.
you hit you can potentially hit the same node or child many times.
Mm-hmm.
Um, so we can keep some sort of maybe memoization
Mm-hmm.
map, a separate
Mm-hmm.
memoization map
Mm-hmm.
that will uh, that will basically keep track of whether we have already found the max
Mm-hmm.
length of a path for a given node.
Mm-hmm.
Does that make sense?
Yeah. Can
Cool,
you do
cool.
those changes?
Yeah, let me give it a go. So I'm going to create this memoization map. It'll be integer to integer. That's node
Mm-hmm.
to max uh, uh, length of the path.
Mm-hmm.
And I'll just call this memo.
Okay.
Um, and then before we do any sort of recursion, we're just going to check if uh, memo contains key node. And if it does contain this key, then we'll just return memo.get node.
Mm-hmm.
Um, and then we'll do, we can
Do you want to
do,
make this the first statement of a function?
hmm, that's, that's a good point. I think it can be the first statement of the function. I think the reason why I didn't is because I'm so used to having a base case up here that I always put
Okay.
it under the base case. But I think you're right in
Makes
that
sense.
we can't do under the first part of the function. And then I'll do memo dot put node and res plus one. We can put actually. Let's just put yeah, res plus one. Yeah, it's kind of like repeating code here. I can just
I think yeah,
yeah,
that's okay.
yeah,
Yeah.
yeah. I think that should work, and I'll add that to the function call here.
Mm-hmm.
We can just do new hash map.
Mm, are you sure? It should be new
Hmm.
hash map for every function call.
Great, great. great point. We'll do map integer memo equals new hash map memo. Yeah. It's
Mm-hmm.
that's true. Yep. And then if it contains key, we'll just return. And if it's in the memo
Mm-hmm.
map, then that
Mm-hmm.
means that we've already found the max
Right.
path length. Mm-hmm.
So can you analyze the complexity now, your improved complexity now?
Yeah. Let me think about this for a moment. Oh, and
Sure.
actually, I think I'm missing a parentheses here. Um, yeah. So this will basically, I think it'll actually just make it O of n plus m.
That's correct.
Cool.
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 Yeah. So yeah, I think yeah, we solved original problem. I have couple of follow-ups like when you already asked about
Mhm.
how what will happen if there is cycle in your current code.
Mhm.
If you
Okay.
don't make any changes and if graph contains cycles, what how it will behave.
There will be a Stack Overflow.
Hmm.
Mhm. Yeah.
And let's say now what I'm want is like from if there is a cycle, all the nodes which can reach to that cycle should return int max as an longest path. So for example, if I change my given example, let's say there is a age from 0 to 1 and there is also age from 1 to 0. Sorry, yeah, 1 to 0. Then for 0 and 1 you can keep repeating. That's why uh, output should have like int max, let's say some big
Mm.
large number, and int max for these two numbers, and for
Mhm.
rest of the things as it is.
Mhm. Mhm. Okay, so if we find a cycle, we just put max integer.
Yeah, for all the elements which can reach to that cycle.
Mhm. Gotcha.
Yeah, there could be the
Okay.
case like, for example, there could be an age from let's say 4 to 1. In that case, 4 should also have int max because you can go to 1 and you can keep repeating from there.
Mhm.
So
Gotcha.
yeah.
Okay. Um. So for I'm gonna tackle this by using extra memory.
Hmm.
Um, and I think I'm going to use some sort of, mm, uh, so yeah, all of these integers are unique, right?
Right.
Um,
The nodes, right?
yeah, exactly.
Yeah,
So
yeah,
there's no
they're
node of
unique.
the
Yeah,
same value.
yeah.
And so I think we can add another input parameter
Mhm.
and call it visited, and we'll make it a hash set.
Mhm.
Um, and so we'll know whether or not we've seen a node before. And if
Mhm.
we come across a node that we've already seen, then we can just return um, integer.maxValue, basically. Um,
Can you make the code changes for me?
yes, yeah. Um, so what contains node. So we'd edit visited. We've already visited this node. Um, yeah, I think we could add it. I want to say at the top here. Let me think about this for a second because I want to make it that if we start recursing and then we eventually um, hit the node, the original parent node, that this is
Mhm.
recognized. So I think um, we can do if visited dot contains node. Um, we can return integer dot max value, and yes, return integer dot max. Uh-huh. So the one issue I'm seeing here is
Mm-hmm.
integer overflow.
Mm-hmm.
Uh, so I don't really know if I want to return max value here, because then we're basically adding one, and then that'll cause an overflow. Um, so I'm thinking that are can all these be positive?
What all?
That all the nodes, are they
Yeah,
from
they
they're
are
all
zero
positive
to.
numbers?
Yeah, they are always 0 to n-1.
Okay, cool. Great. So maybe I can just return -1 here.
Okay.
Uh, and then if memoed up, we can do uh, if uh, ooh, but then this is math.max. Actually, yeah. Actually, sorry, I'm going to go back and make this return integer.max value,
Mm-hmm.
and then yeah, then we can go if res equals integer dot max value, then return -1, else return res plus 1, and then we'll just return uh, memo dot get node,
Mm-hmm.
and then we will here we'll do kind of something similar. If we'll actually extract this, and then we'll put int um, int max length, or yeah, max path length, and then we'll do if max length is equal to -1, then we'll do integer dot max value, else we'll do max path length. Okay, so yes, so if we say, so just to run through an example, if we pass in 0 to this DFS,
Mm-hmm.
it will return or it'll return an array of children just containing a single element 1, and then we
Mm-hmm.
do the one, but we add 0 to this visited
Mm-hmm.
set, and then we do a DFS on the node of 1, and then we
Mm-hmm.
come back into here, um, visited, and we add 1 to the visited set,
Mm-hmm.
um, and then we get uh, 0 in 2 as possible children, but
Mm-hmm.
we first do 0, and then we come back into this kind of third DFS, and but 0 will already be 0
There.
will be in the visited array, and so we'll return integer.max value, and that'll always be the max value for res. So even when we go through 2, there's no way 2 is going to
Mm-hmm.
whatever the length of 2, assuming 2 doesn't have a cycle,
Mm-hmm.
there's no way it's going to be max value. So then we'll return -1, and then we'll have that up here, um, and then we'll add that to the res array at the specific index, like you had mentioned up here. Does that make sense?
Yeah. Do you also need to pass the set where you will pass the set visited says from the original call?
Yes, good point. Uh, and this one we actually are going to instantiate it with every new function call, if
Makes
I'm
sense.
not mistaken.
Hmm. Right. Cool. I think yeah. That takes care of first follow up. Like I've the second follow up is Here we are assuming the ages have just single weight, like weight of any age is single weight. Now let's say that our ages could be positive weights. It may not be one. So it could be every like 0 to 1 can have weight of 4, 1 to 5, 1 to 2 can have a weight of 5. So each age can have different positive weights. So if that is the case, like what changes you will require in your code?
Positive. Um,
Did you get the
Sorry,
at least the question?
I didn't quite understand. Are you saying each
Yeah,
node also have a weight assigned to it?
not node, ages. Like for example, when we consider the length of a path, the number of ages was the length of a path, right?
Did you say sorry, ages?
Yeah,
Um,
ages in the
oh,
graph.
edges. Oh, I'm sorry. I'm sorry.
Edges, so sorry.
Okay, gotcha.
Yeah.
Gotcha. The number of
So yeah, so number of ages was the was the answer for any node, right?
mhm. Yep.
But rather than that, what I'm saying is every age will have a weight associated with it. For example,
Uh,
0, 1, and a 4.
uh-huh.
0, like 1, 2, and like let's say 5. Then the longest path from 0 ending at 2 would be like 4 plus 5, and
Mhm.
not just the
Mhm.
length of that. Let's say this is
Mhm.
1. So the longest path originating from, let's say this is not there.
Mhm.
And if that this is the case, the longest path originating from 0 would be of length 10. 4 plus
Mhm.
5 plus 1.
Mhm. Understood. Okay. Let me think about this for a moment. Um, so we need to keep track of ah, uh-huh. Okay, so this kind of going back to
Mm-hmm.
what you had mentioned in the beginning,
Mm-hmm.
it sounds like we're going to have to implement a separate class, or we don't have to, but I think for to make things neat,
Mm-hmm.
it might make sense. So, like, I could implement a second class and call it node,
Mm-hmm.
um, and this could have like uh, um, like uh, integer parent,
Mm-hmm.
uh, integer child, and uh, int weight.
Mm-hmm.
Um,
Will it
and
be the node class, or will it be the age class?
mm-hmm,
Mm-hmm.
mm-hmm. Yeah. So you're right in that it probably would make more sense to call this edge,
Mm-hmm.
because this basically represents the connection between parent and child, and then the weight
Okay.
associated with that, like you were talking about. And so instead of like an input of a map to a list of integers, we could
Mm-hmm.
do a list of edges.
Mm-hmm.
Um, and let me just change the code uh, as needed. Uh, this will remain the same. Map memoization, that should remain the same. Integer memo node. Yeah, that's the same. This should be edges. Um, and then res 0 int. Yes. Uh, and so instead of 1 here,
It would be.
uh,
It would be
yeah,
okay.
it will be uh, res is, so we get a list of edges.
You can't do it here, right?
Hmm 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 right, right. Uh, yeah. Okay, I see what you're saying. So res will be method mux path length plus, um, and this will also be an edge, right? Uh, child dot weight.
Are you sure?
Wait, oh, sorry. No,
I think
sorry.
it should be like result is equals to max of result, comma, path length plus child plus weight.
Um, max result res dot. Uh, oh, like right here is what you're saying. Plus
Yeah.
uh, child. It could be here or it could be up here, right?
Mm.
Plus child dot weight. Does that make sense?
Right. Makes sense. Yeah, I got it.
Okay. And
What changes you will do on line number 14.9?
yeah, so we can return still max integer. Uh, so that's I still need to make changes here. I'm going to get an overflow potentially. Um, so yeah. I think what you said before makes more sense. So we can basically say if path length is equal to integer dot max value,
Mm-hmm.
um, then we just return that. Um, else we'll do path length. Oops. Oh wow. Didn't mean to do that. Else we'll do path length plus child dot weight. And so here we don't need that. Uh,
Mm.
yeah, I think that should do it.
Cool. Awesome. Now let's say like we are done with this code. What kind of different test cases you would like to consider to test your code against?
Mm-hmm, mm-hmm. Yeah, so we can start kind of simple.
Mm-hmm.
Uh, test case. Ooh, case. I don't know why it's auto correcting. And so we can kind of so basically it's like um, we can like create. I don't know. I'm just gonna basically give us a list of these tuples to represent the edge case, unless you want me to like instantiate a map and start adding.
Even rather than tuples, you can just say that like okay, a graph. You can just explain in plain English, and that should be okay.
Oh, okay. Rather than writing it out here. Yes, yeah. So I would just, have our kind of base happy case,
Mm-hmm.
like kind of like almost the original one you had set here.
Okay.
Basically a test case with no cycles.
Mm-hmm.
Um, I would have a test case uh, with uh, or I would have maybe multiple test cases with varying cycles,
Mm-hmm.
um, and I would have like a null test case, and that's actually something I didn't check here. Is if like do a null check if uh, graph equals null, then return collections dot empty list, something like that, depending on what you'd like returned with null. This should be collections. Um, and then I would also have test cases with uh, just varying weights to make sure that
Right.
uh, to handle all the different possibilities of weights and things like that, just to make sure that how I'm
Mm-hmm.
calculating weights per edge makes sense.
Right. Cool. Yeah, I'm happy. Like these are good set of test cases you come up with. Um, like yeah. I think yeah, we hit the 45-minute mark also. Maybe
Mhm.
like this is time where we move to the second part about the feedback.
Great.
Um, right. So one feedback you already encountered is like you need to brush up the complexity of known graph algorithms, right?
Got it.
That stands there. And for the rest of the feedbacks, what I will do is I can start from beginning to end. I will say like what I liked and what you can keep doing and what could have you done better in terms of your approach. Um,
Okay.
okay.
Yep.
So yeah, I like the fact that spot on you asked the right clarification question about is graph cyclic or is graph non-cyclic. That was spot on. You also asked how the graph is represented. These are good clarification question at the beginning. And
Mhm.
keep doing that. I like the fact. I keep doing that. That's a good way to go. You straight away talked about the solution by using DFS, depth first search. Uh, do you also get breadth first search as an alternative solution while you're thinking about solution, or you just got DFS?
Um, I'm very comfortable with
Mm-hmm.
DFS, so I
Mm-hmm.
usually just go straight to that.
Okay. Like, do you get that this could also be solved with breadth first search?
Um,
Okay, no worries. If
yeah,
you didn't get it,
I need to think. Sorry, I just need to think about it more, but not like instantly.
okay, cool. But like, yeah, this could easily be solved with breadth first search also. But if you didn't get that, what you did is good. But if like in some sense, whenever you get multiple solution, to talk about like it could be solved by both, and why
Mm,
you will choose one over another, that shows that you kind of can make a decisions. You can kind of talk about trade-off.
mhm,
Um, but yeah, in your case, in this particular case, you did not get that second solution, and it's okay, and it's good thing like you did not waste time to find the alternate solution. But if
mm,
like if you would have got both of them, you could have got a feeling that okay, this could be solved by DFS or it could also be solved by BFS. Then you should talk about it and why you chose one. But yeah,
mhm,
this wasn't the case, so it makes sense.
mhm,
um yeah, so another thing, like you once you say that you will solve it by DFS, you straight on went to the coding.
mm,
um this is the place where I would suggest you to tweak your approach. My
mhm,
suggestion would be, once you talk about the solution, analyze the complexity of a solution. uh, it's best, but it's the best case if you can even prove the correctness of solution. But not if it is straightforward, prove that, but don't worry about it. But at least the complexity analysis. Once you talk about the solution, do the complexity analysis, and to ask interviewer whether he wants you to go and code this solution. Like it shouldn't
oh,
happen that if you can spend 5 more minutes and you can optimize it and can give him the optimized code rather than writing an unoptimized code. So my suggestion would be, whenever you share the approach, straight away do the complexity analysis and follow that up with a question like, does this work for you? Shall I code it?
gotcha,
So that like you are on the same page.
gotcha. So I just said DFS. I didn't give
Mm-hmm.
complexity analysis or
Right.
how the DFS should work. Instead, I should be like, I'm going to go with DFS. The
Mm-hmm.
complexity analysis will be, or complexity will be roughly this, and this is
Mm.
roughly how it's going to work. Would you like me to go about coding this up?
Right, right. Yeah, this will avoid two cases. Like one is your approach is totally wrong, or you are solving it for some wrong problem.
Mhm,
You did not understood the problem, and you are writing a code for some wrong problem,
mhm,
and you waste time. Or you are solving it for the right problem, but you are not writing an optimal code. And we were fortunate enough here to have time to go back and optimize it, to involve memorization. But it
mhm,
might happen that you were time ticks just before you are done with the code and there are just 4 5 minutes, and rather than giving you time to uh, optimize it, interviewer might choose to focus on another area, and he might consider that you are not able to come to optimal solution. So my suggestion would be, once you are done with approach discussion, follow up with the follow it up with complexity analysis and ask him if this is something he wants or you should try for something else.
Gotcha. Gotcha. I like that.
Yeah, the good interviewer won't penalize you for it, but it's not, if you are not a lucky, it's not your lucky day. Interviewer might not be that well trained and he might not poke you, and at the end he has nothing to lose, right? It's you who is who is investing time and efforts, and it's
Yeah, it
better
doesn't.
to.
Yeah, it's not much additional effort on my part to just do that.
Right.
So, hmm
Yeah,
makes.
so that's the one thing. And yeah, and in coding you were flawless. I really enjoyed the way you go ahead. I like you straight away talked about modularizing code, writing two functions, keep doing that. That's a good thing.
Nice.
Yeah, and at the end, so let me know like how much for which roles you're targeting. Is it a mid senior, senior, or it's like starting roles? Because like I would like to add few things if it's based on
Yeah,
like which levels you're trying to apply
yeah.
for.
I have 5 years of experience. This is
Mm-hmm.
kind of my first cycle of interviewing I've
Okay.
ever done. I've just been at one company for 5 years.
Okay.
And my goal is senior, but mid-level to senior is
Yeah. So
goal.
yeah, my suggestion would be to include validation while writing code. Don't assume that input is always correct. Try to write a validation code. It's again like you 30 seconds extra. And my suggestion is like to add code to validate the inputs. Um,
So like
yeah.
a null check, or and then maybe ask the interviewer if it's possible that there's there could be other issues with the input.
Right, right. It's okay, and it's totally fine if you're thinking like you are against running against the clock. Once you are done with the code, do talk about that. I should have added validations. That shows that you are a senior person and you
Hmm
have some coding experience. Like, try to give all the signals to him. Right. It's basically he's trying to find a teammate, and he would like to have a teammate who thinks about validation, who thinks about test cases.
mm
Right. So once you are done with the code, ideally what I do is whenever I'm giving an interviews while writing code, I first thing I do is I validate the input, at least basic validation, to give him the sense that I do care about input validation. It's
Gotcha.
interview for me, like I don't take interviews as trying to solve problem. I take interviews as giving him as many signals of being a good software engineer as possible. So
Mm,
yeah, that
gotcha.
is a place where I take the advantage. Okay, like yeah, let me give him a signal that oh no, I'm just not a guy who write a code. I'm a guy who takes care of who takes ownership of my code. So yeah,
That's
and once you are done with the code, and rather than pausing there, what you can say is like if there is an awkward pause, you should think about test cases for your code rather
okay.
than he poking you.
Oh, okay. I
Yeah,
got you.
yeah, here I was asking you some follow-up questions, so that's okay. But if there is an awkward pause and you think like, okay, you're done with the code, there is no, he's not asking any follow-up question, it's a
I
good
can
time to
be
showcase that my testing skills. Yeah.
Gotcha. Gotcha. Okay. That makes sense. That makes sense. Cool.
Cool. Awesome. I don't have any other feedback. Like, yeah, I really like the way you took care of like follow-up questions, and you are so and you are always about keeping your code clean, so that's a good thing. So yeah, keep doing that.
Mhm.
Just these tweaks in the steps you follow to solve the problems, just to be a good interviewer.
Mhm.
You are a good candidate, but it's like just to be a better interviewee to help your counterpart to gather all the signals.
Gotcha. It sounds like what you're saying is it's as much about optics as
Right,
solving the problem.
right. Yeah,
Uh-huh. And quick question: if I had was able to solve the time complexity, would you have given me a thumbs up? I'm assuming because I could do
yeah,
the time
yeah,
complexity, I
yeah,
would
yeah,
fail.
yeah.
Oh,
Currently, I would have given you a thumbs up. Still given you a thumbs up with low confidence.
oh, okay.
Um, But like if you had come up with a clean complexity analysis, I would have given thumbs up with high confidence.
Nice, nice. Okay, great.
Okay,
Thanks so much. This has been quite helpful.
cool. Yeah, I think after the interview, you also need to submit a feedback for me.
Yep.
And yep, cool. Yeah,
Okay.
all the
And
best
this,
for your. Mhm.
sorry, one last question. So this would be a question that is asked by I know I can't ask you what company you're from. This is supposed to be anonymous, but I can expect a question like this from like any kind of top company or startup. As far as like the difficulty of this question goes, how would you like rate it?
Yeah. So it's it's a Google level question, like basically. Yeah.
Okay, gotcha, gotcha. All right, thank you so much. I appreciate it, man.
Yeah. Cool. Awesome. Yeah. Have the
All right,
rest of the nice day. Bye bye.
all right. Take care. Bye.